Thank you for the invitation. My name is Anthony Matheri, and I'm going to give up presentations on the climate resilience and coefficients approach to circular economy that's integrated waste to energy to green energy systems in a Commonwealth nations selected South Africa. Green revolution and disruptions of the natural resources and the social ecosystem impacts are becoming increasingly in the fourth industrial revolutions. This is due to enhancements of the adaptive capacity for the complex global challenges in advanced nexus approach to sustainable management. This serves as a pragmatically that was isolated and understanding of interrelationship of the nexus, human well-being, resilient ecosystem, energy security, circular economy, climate change that coexist within preliminary boundaries. About 45% of the greenhouse gases produced come from the 10 billion tons of waste materials and food we generate in every single day in our society. Climate change conversations have been mingling a lot lately, and a shift to renewable energies has a few solutions against the greenhouse gases or emission. Climate economy approaches as part of the Africa is part and will be part of parcel of the Africa transformative efforts to sustainable development. And the position outlined as follow, where we're going to have introduction, climate, land, water, energy nexus, and food nexus. Energy security has facet of water, food, and energy systems resilience. Reliable integrated waste management system with the nexus as well, and bio-waste utilizations, carbon tax, and the climate resilience in the fourth industrial revolution, adaptation of the climate change technology transfer, policy and governance, nexus, and we're going to elaborate the research gaps, and then we're going to go to conclusion and commendation, and then at last we're going to do the recommendations. The global web of the mutual interlink an ongoing disruption of the environment, and is likely to alter the stability and availability of land, energy, water, food that is central to climate change policies and natural resources management. Holistic and integrated approach to resource planning and management have been largely embraced by the decision makers and stakeholders through the benefit of the Nexus approach. Nexus has the potential to unlock groundbreaking solutions to complex problems with appropriate models and climate change mitigation. The enhancement of climate technology development and knowledge transfer through the technology mechanisms of greater public-private cooperation, that's cross-sector partnerships, is widely discussed as a climate change conference and elaborated in the Sustainable Development Goals. And the specific on this agenda of interest is SDG 2 of the Zero Hunger, SDG 6 of the Climate, Water and Sanitation, SDG 7, Affordable and Clean Energy, SDG 13, which is taking action to combat climate change and the impacts. The historic Paris agreements provide countries with a strong climate change response by keeping the temperature below 2 to 1.5 degrees centigrade. And intergovernmental climate change panel have recorded the following, where from 1901 to 2010, warm ocean and division snows by ice by 1.7 million kilometers square, with the rise of the sea level by 19 centimeters. And 1880 to 2012, increase of the temperature by 0.85 degrees centigrade was due to warmer climate. And 1990 to date, global emissions of carbon dioxide has increased by 50%. Energy security exists where the uninterrupted availability of the energy sources distribution at affordable prices to the consumers. And with frequent power rationing, that's power rationing, which is load shedding in Africa and most of the African countries, and many other African countries, which ranges for hours, days, and energy security still remain a key theme. And all these lies on good governance and implementations. And circular economy is expressed in 3 domains, and these 3 domains include the resources, governance, and security. And the domain requires the inclusions of the policies and institutions expertise, natural resources, environmental science, and engineering expertise for the mutual perspective of the multiple decision making. And priorities area for climate change inclusions is linked due to decarbonizations of the economy, digitalization of the systems, decentralization of the production, transition to 100% renewable energies, carbon taxations accessible to sustainable financing, and strong commitments by the major emitters, and commitments to achieving carbon neutrality by 2050. And on the reliable integrated waste management and the nexus, the popular development, urbanizations, and economic advancements, improvement in the expectation for the everyday comforts, increase the amount of waste generation in the cities, and reintroduction of the emerging contaminants into our own waste streams. And all these waste pose sanitary, health hazard, and environmental risk. And all these contaminants end up in the water bodies and the landfill, and with the health hazard to the environment as well. And promoting, and all this promote pollutions to the environment, thus putting a high strain on the socio-economic health sectors and the climate change. Tackling integrated waste management and disruptions and energy securities requires stipulated regulations and policy that coordinates waste administration framework. And in our own investigation of the waste quantification process, the sustainability characterizations to assess the composition of the anaerobic digestion, to assess the amount of the quality of energy generated by the city of Johannesburg, was carried out by our own research teams at the University of Johannesburg. That's in the city of Johannesburg. The outcome indicated that 1.4 million tons of local waste were generated of the population of 6 million residents. And returning alone cost about $5.7 million every year, when electricity brewing cost about $6.2 million each year. And organic waste was the most bottomless segment of the municipality solid waste, representing 34%. And recyclable secondary, probably that was paper, plastic, and glass, was the biggest part with 12, 9, 19, and 9% respectively. The recommendation was to divert the organics for biogas productions and plastic for bio-oil and construction composites, textile and paper for combustion, glass, special cares, and e-waste was to be recycled. There are obstacles confronting the municipality solid waste management within the city. And some of these obstacles are the interrelation of urbanizations, economic growth, change of living standards that require complexity of the waste streams, overreaching of the supernaturals, and lack of locations and facility to expandate waste separation to source, and intelligent network which fall under infrastructure. That can be the truck collectors, IoT being automated, recycle with the insensitive to the user, availability of the recycle plants, and some of this technology of artificial intelligence. And in collaboration to integrated waste management technology, and this come on handy, costly compared to landfilling and compositing. And detachments of waste at source and embracing zero waste financial motivation urge families to diminish the secondary. The future of the digital disruptions and transformations of the industrial platform, energy, food, water generation lies on the decarbonization, decentralizations, electrification, and digitalizations. That's sustainable industrialization and diversifications in the digital era. Technologies in the era of the digital transformations are becoming commercially viable to the integrated systems and services that enable sustainable management and coefficient of integrated waste management and energy use. And all this goes to energy production as well. And an anaerobic hierarchy process, that's multi-criteria decision analysis, SDA, was used in the decision making for the most appropriate waste to energy technology systems and the selections. And 4 criteria were considered, and those criteria were environmental, socio-cultural techniques, and economic criteria. For wastewater technology, wastewater energy technology options were considered, and all these were included like anaerobic digestion, compositing, installations, and landfilling. From the results, there were 54% acceptance of an anaerobic digestion towards meeting the 4 criteria stated to achieve the goal of environmental preservations when landfilling had the least acceptance with 5%. Insulation and compositing has an acceptance of 24% and 14% respectively. And the pictures or the figures show sites of the landfilling, biosolid beneficiation from the wastewater treatment plant, especially from the biosolids which activated, and adoption technology is used to adopt the metals of the rivers and the wastewater plants, and upscaling of the waste to energy technologies in South Africa, more of biogas to energy. And in our study, that's basically on the quantification and characterization of the biomasses with regard to proximate and ultimate analysis and anaerobic digestions was determined. And higher moisture content of the solid and volatile solid show that biomasses are easily degradable and thus are visible for anaerobic digestions to aid the bioenergies. And the carbon-nitrogen ratio was an important factor in bacterial stability and nutrients balance in anaerobic digestion processes. And the carbon-nitrogen ratio for most of the substrates was within the range of 15 to 30, except for wood, sawdust, and bagasse that exhibited carbon-nitrogen ratio of 200, 230, and 165, respectively. And carbon-nitrogen ratio was within the range of 15 to 30, and this promoted high digestion stability because of higher carbon content provided by the nutrients required for bacterial growth, and thus increasing the production of the biomethane. And biomethane potential was experimentally determined using automated methane potential test system. And in this system, optimum BMB tests for different biomasses was performed to determine the anaerobic biodegradability of organic matter. That was more mono and co-digestion. The overall observation clearly showed that co-digestion of the substrate created the optimal balance of nutrients and microorganisms and favorable working environment for anaerobic digestion. This enhances high methane production without exhibiting poisoning of the microorganisms or the microbes. Our finding demonstrated that the visibility of energy recovery from the biomasses was affordable, sustainable, with zero carbon emission. The use of the bioenergy, that's biomethane or biogas, which is biogas upgraded to biomethane, was demonstrated using the city of Johannesburg metro vehicles or metro buses and small-scale production for cooking and lighting in the community or in the villages. And the biomethane had the same composition with the natural gases, and the digestate was recommended to be used as organic fertilizer for crop growing, and highly recommended for hydroponic, aeroponic, small and large-scale farming. The study of the removal of the heavy metals from the wastewater using activated biomasses demonstrated high percentage of removal at a lower cost. Biochar produced from the biomasses can be used as an alternative absorbent for the commercial activated carbon or commercial material for the removal of the trace metals in the wastewater treatment plant streams or the rivers. Waste plastics was converted to bio-oil using pyrolysis process and used as a construction material as well. An ongoing project on the optimizations of the bioplastic production yield good results with 15 days of degradability of inside the soil and wastewater. And this is a higher project to be looked at on how to utilize the bio-waste to make the bioplastic that is more degradable. Economic transformations and creation of employment through circular bioeconomy and digitalization will be one of the conference of parties in the Green Deal agenda. This is with the transition of the National Development Goals 2030, low carbon emissions, economy, and sustainable development goals. The carbon tax, as defined, is a levy on a carbon content of fuel. That's industrial energy and the transport sector. Carbon emission trading in form of carbon pricing. The tax offers potential cost-effective means of the reduction of the greenhouse gas emissions by shifting the cost of the society to the companies, and thus create to the company themselves. And this creates the emissions taxations. South Africa have spearheaded the developing countries in the Carbon Tax 2019, and this was enacted as a Carbon Tax Act number 15 in 2019, meant in curbing the carbon emissions, has mitigation to climate change, cost-effective and economic efficient. The benefits of the carbon tax will be more effective on the cross borders, and this is especially with the currently signed the African Continental Free Trade area. And on the energy and Industrial 4.0, that's the fourth industrial revolution, the nexus pillar and sustainable development needs to be explored. And relatively straightforward to obtain the national data for the nexus is widely a big challenge. Small numbers of bodies share the production, transformations, and the consumption data. This remains a key challenge in mitigation of the climate change. And the efficiency and the implementation of the nexus is dependency to higher accuracy of the economic database that supports sustainability. Data gap is even larger in full cycle of the technology, if technology is considered. The analysis of CREO, which is climate change, land, energy, water, and food interlink, can be analyzed well by the use of the artificial intelligence tool. Most probably the artificial neural network, ETC, sustainable statistical tools that can be multi-criteria decision analysis, MCDA, and conventional modeling concepts. Currently, combating anthropogenetic climate change in developing countries is carried through the transfer of the environmentally sound technology, that is EST. This is widely recognized period for global environmental policy, climate change, future policy in developing countries. I like to be promoted by the technology, by climate technology transfer and public-private cooperation. That's a cross-sector partnership through the technology mechanisms of the water, energy, food nexus, and inclusion of the gender. Building partnership mechanism can reduce costs and increase local clean development mechanism, which is a CDM. Climate change policy and technology transfer minimizes the transaction costs, strengthens the collaboration, increase capacity building, increase public trust and accountability, and enhance environmental governance under the Climate Change Convention. Climate gas, GHG emission, and climate risk are not only on the metros or the big cities government concerns, but also on the rural government oversight concerns, especially the climate governance. The driver, consequences, and dynamics of the climate change cut across jurisdictions, boundaries that require collaborative and coordination of the governance across non-government and government sector. Climate change governance is within the broader political and socio-economic concept negotiable with the Conference of Parties, COP. The issue of the regional security, that's a power imbalance, are the interests overriding the climate change agenda. Formation of the transboundaries with the globalization makers create integrations and enhance the benefits through the climate land and nexus and accountability of the distributions. Creations and promotion of the gender equity and environmental enhance the nexus investments and implementations. The three fundamentals of planning are economic developments, environmental protection, and equity through social justice. The concepts of the nexus have received the business, researchers, research institutions, and the private sector and public policy makers, or the public sectors or the policy sectors, with a few implementation projects on the ground. The major discussion on how to implement and shift from the ideal concepts of the theory-based to practical and policy. Versatile methodology to quantify the interlink between the nexus and climate change is much required. Improving the existing formation of the methodology and practices is of higher priorities to advancing the adaptations of the nexus approach. And those approaches is as defined. And on the conclusions, the interlink between nexus manifesting, providing, exploring opportunities that explore the disruptions, the policies, the alternative use of the resources, sustainable resource and management, and minimizations of the environmental impacts. The nexus and climate resilience is of great opportunity and integrated and managed by the destructive technology and a more sustainable manner. Advanced knowledge, upskilling, of course, and optimization of the mitigation and adaptation within the coordination of the sustainable land use and management across sector is much required. And climate action future policy in developing countries or the Commonwealth nation is likely to be promoted by the climate technology transfer and public-private partnership that cut across borders. And on the recommendations, as stated, investments is a key issue. And great investments into nexus with the strong collaboration and multidisciplinary is much required. And the government should work together to achieve the green circular economy or bioeconomy and digital economy with smart and intelligent novel solutions. Sustainable development goals, especially 17, needs to be widely exposed and all the policy clarified. And development of the new tools to be investigated and interconnection of the nexus, that's food, energy, food, with land and climate change need to be explored. Research and development should be enhanced before making decisions on sustainability and efficiency. And better understanding is required for the trade-off between the nexus and the ecosystem. It's important to take actions of the spatial reach of the intersectoral dependency. And data shortage should be reduced by encouraging open source data, open source science, with the digitalized systems and capacity building support on sustainable monitoring and data management system. Enhance capacity building, knowledge transfer in the digital economy as well. And at last, enhance efficiency and sustainability of the green climate change. I want to acknowledge the foreign organizations, people, and institutions that supported the research and data collections and knowledge transfer and capacity building. The transformation of the decision makers is good to have a data-driven culture that is necessary of the driving achievement through circularity and digitality. Thank you, and thank you for listening, and let's enhance the achievement of a circular and digital economy. Thank you.